Hi guys, so today's challenge is this Extreme Networks Summit X450E. This is one of our event units. It was popped on a site for a while. It was quite epically filled with plaster dust and everything else, and it stopped working. Now we've got activity down here on these. We have no activity there, and none of the ports ever seem to wake up. So we're going to have a dive into this, see if we can work out what's up with it. Odds are on it's going to be capacitor problems, and see if we can get it going again. As you can see, I'm zoomed quite a ways in. My microphone's in a really awkward position, so if I do bang it and anyone's wearing headphones, then I apologise. So this is a PoE camera, which I'm just using for testing. We can get rid of that now. This is a Summit Networks X450E-48P Extreme switch. We use a lot of these on events. A lot of these have come out of data centers very recently, meaning that for a while these switches were plentiful and cheap. This is a 48 port commercial grade, actually data center grade PoE switch. They're big, they're bulky, they're fairly bomb proof. However, there are situations you can put equipment like this into which do not do good things to them, and in particular this one had been basically put into a building site. It and its twin ultimately did not survive the experience, with the twin dying outright, and then this one becoming intermittent and dying shortly thereafter. These are actually Linux-based servers in their own right. They run Linux. They are properly fully managed, so you can do just about everything up to and including routing and DHCP on these. Because they're so flexible, and I find the command line on these really easy to get along with, we keep them for event use. We're taking them out of any main sort of frontline service that these were in now. The only ones that are staying in frontline service are the ones that we know the history of. Any that we have doubts over history, we got a large number of these scrap, which we put a lot of effort into getting them running again. They are now all in our event stock, and obviously we make sure that wherever we're deploying these, we have a spare unit as well, or spares for the unit. Most of the things these suffer from, if you go online and pick one of these switches up, it's not a bad deal for what they are, and for home use or home lab use, they are great. You have 48 ports, you have 4 SFP ports on the front, which are 10 gig capable. You have a console port on the front. You also have a management interface on the back, a separate Ethernet port for the processor card. So you can physically separate management traffic from the main network. They quite frequently come with faulty fans, and those that don't, the fans are on the last legs of their life. We have deployed some that are new and guaranteed, and we have had fan failures in those as well. That said, you buy a Netgear switch of the same sort of era, you'll get the same problem. So what I'm going to do is we'll just slide this off, and we'll have a quick look at what's in there. You are zoomed quite a way out. Unfortunately, this thing is enormous, and I will try and zoom you in as and when we start looking at things. The lid is loose because I've already had a quick look at it to check for the obvious things. So let's just get this off. There we go. And as you can see, there's not a tremendous amount of space in here. So you don't necessarily need to see all of this at the front, so I can zoom you down a little bit more. A little bit glary off of this. There's actually nothing here, so you're not missing anything. So we've got a number of high-powered fans down here. This one, and this one have been replaced. That is an original one. We have even a higher power centrifugal fan here, and we have fans here. These things are loud. It's not something you'd like to really have kicking around in your room next to your bed, or in a living room where people are going to want to try and watch TV. They are quite modular, so we have a module up here, which I believe is the LED controllers. We have the PoE section down here, And then we have the fabric, which are these chips here and this chip here. We then have a processor here and a very large power supply here. Now, there are known faults with these. There are things we run into quite often. The most common one being the capacitors on the processor board. So we're going to hoik the processor board out in a minute and have a look at it. We will check the caps. Even though visually they may look okay, we're going to check them because they fail that frequently. There is also a CF card in here that contains the operating system. We're going to have a look at that. But before I think we go much further, we do get a boot console out the front of this. So we will get it fired up. I will get OBS fired up so you can see what I'm seeing. And we'll boot this up and see if we're getting a kernel panic or anything that can give us some clue as to what's actually going on here. It may just be that we need to factory reset this one. I'm not convinced on that because this did work. It worked when it came out and it didn't work when we tried to use it again. So I'm going to have to turn the power on. I'm going to need to go and get the laptop and the console cable, and we'll get this fired up and we'll see where we can get with it. Back again. So we have the laptop set up over here. We have our serial connection via the docking station here into the front. We have putty running over there. So let's fire things up and see what happens. This is going to be loud, unfortunately, so there's not a lot I can do about that. So we've got a self-test. It is booting. I don't know if you can see it on the video, but we've got an activity light and a power light there. But that is all we've got. Okay, that's slightly concerning. We should be seeing a bit more of a boot process here, so I'm wondering if we need to swap that CF card out. It would be nice if it's just this problem with the CF card. It's possible. Okay, well, let's turn it all off again. I'll pause you and we'll go get another CF card. Right, let's try that again. We've changed the SD card. Hopefully we'll get something a bit more this time. Networks power on self-test. And nothing. That's not really looking that hopeful. It looks like we might have a slightly dodgy processor board here. Now I'm not sure if this light flashing means anything. It's hard to know. Right, let's power it off. I've already got the screws out of the processor card, so let's just gently pull that out. So what's normally the cause of issues on these is these caps here. But they do all look fairly healthy. There's no sign of any leakage. Nothing to suggest that there is anything bad going on here. There is some, I don't know if it camera catches it, but you can see the board is a bit mucky. That's from where it's been cleaned. Now, we appear to be running and we appear to be completing a self-test. Now, a couple of people have suggested that could potentially be an issue. But I'm really not sure. I don't quite know where to go with this one again. I do have another processor board, so we could potentially try that. Bear with me. Let's pop this back in, get it dried, and see what happens next. Let's have a quick look and see if that has made any difference. I very much doubt it has. See, we're getting a pass on the power on self-test, which is strange. There can't obviously be anything major wrong here. I don't really want to have to go prize the CPU board out of another machine. But we are definitely not doing anything. I wonder, is it as simple as I'm on the wrong board rate? That's possible. Let's just try that. We don't appear to get anything now. We have a flashing management light on the front as well. This is... I do wonder if we just need to leave this. Let's change our session settings again. We'll go back to 9600 because we know we were getting something out of that. Turn flow control off, we don't need it. Maybe we should just leave it for a few minutes, see what happens. I do have another compact flash here. So this is the original image. This is from a 24 port. There shouldn't be any difference, there may well be. I definitely need to make an image of these cards because actually obtaining an updated image seems to be impossible. So I'm going to stop you recording on both the console and this, and I'm just going to leave this a little bit and see if anything more interesting happens. So I've grabbed another known good switch. We'll have a sip of tea and turn this on and see what a known good one actually does. Now, as you can see, we're straight into the boot. So we should do our power on self-test and go straight into the bootloader. So my guess is there's something fairly fundamentally wrong with that CPU board, but I have no idea quite how we would go further into troubleshooting that. As you can see, it's loaded the image from the CF card and we're up and running. So definitely something not right with this switch. We have a solid management light. This one is fully screwed together, which I really don't want to take it apart if I don't have to. And there we go, we're into extreme OS. So I'm not sure where to go with this one. What we'll do is we'll pop that CPU board out and I'll have another sip of tea, and maybe we'll check those caps. They look good, but obviously appearances can be deceiving. So we'll check those caps and see what happens. There we go, some peace and quiet. Right, I appear to have ordered the world's thickest solder here. Can the weller even melt this? Yes, it can. So we'll just put a bit of solder on those joints. And we'll just rock this cap out. There is quite a large power plane on this board. Now if these have gone low, so it won't be a surprise. I believe I've done a teardown on one of these switches before. It was one where the audio didn't render properly or didn't capture. There we go. This is just a cheap capacitance meter. It doesn't do ESR or anything like that. I do actually have one that will do ESR. It's shorted. So out of circuit, we're getting the right value-ish. It's close enough because we obviously heated it up. 200. Do we replace these anyway is my next question. Trouble is these could be circuit board effects, but I have had multiple cases of these being dead. The other thing is that snap hat battery gone as well? I think for now we will pop that cap back in as best as we are able. I'm going to have to do this off screen for a second here because I need to balance this. But I wonder if we've got a bigger problem with this one. I do have spare batteries for those timekeepers, So replacing that is not impossible, but I do feel that we might have to go and do a bit more digging as to what might be going on here. I don't really want to abandon this switch. I'm having real trouble getting this solder to flow again. What we might have to do is just tack. Oh, that's going to help things. Just tack that capacitor back on for now. I'm not convinced because I've had these exact caps fail on these boards. That one reads okay on the surface. Shall we recap it anyway? Let's just tack him back on, and then maybe I will go and see if I have sufficient parts to actually recap this. Oh, this one is not easy to get in here to do this. Even with all the light we've got above the bench, I'm struggling with this one. One. That's nice and solid. Two. I very much doubt that's made any difference at all, but I guess it can't hurt to check. This is where it comes in handy knowing what the boot process actually means. We've basically got the switch there saying to us that, you know, I think I'm happy, and then failing to boot. So there's obviously more going on than we think. Let's just power it up. Oh, hang on. It does help if you plug the terminal in. Let's see what happens. It's the same again, we're passing our self-test, but that's it. Let's just pop that snap hat off. You would hope that it's going to be intelligent enough to deal. That's what they look like without the battery on. As I said, you would hope that they will be intelligent enough to deal with the loss of that MV RAM. And that's made no difference at all. But I believe that that MV RAM is completely toast. I'm just going to stop you again. Right, we're back. And what I'm going to do is, we've got a reset switch on the back. We don't know what that does. But I am going to try and see if we can get into the boot ROM. But I suspect that's not going to be the case. So spacebar down, turn it on. No, there's no boot ROM there. Okay. What have I got to hand that I can push that button with? Oh look, what about that? There are some benefits to having a messy desk. So that on the back of the CPU card is a reset switch. What does that LED do when we reset? I can't help but believe that that LED is telling us something. Alright, now this is where we need to weigh up quite what the point in going any further is. Yeah, these switches are useful. I do have a fair few of them though. I know I've not checked power rails, maybe I should do, but everything else is giving every appearance of being alive. I have to weigh up the pros and cons of putting the time into fixing this. And the way I look at that is my time has a value. Admittedly, there is an extra bit of value in doing this because it's creating a video for you guys to watch. But I need to be careful that the time that I spend on this and the parts I spend on this do not exceed the replacement value of the bit of kit. Or, to be fair, come reasonably close. This bit of equipment has a bit of a checkered history. It's been abused. So there's no guarantee that there won't be another failure. When we obtain these switches, they've come from a clean operating environment. They have been proven. but this one has been into an environment that is decidedly not clean. Now, on top of that, if I keep this running, let's just kill that. Sorry, on top of that, if I decide to get rid of this switch, which is where I'm leaning now, I then gain a spare power supply, a spare system board, spare PoE board, spare LED board, and a lot of fans. So, you know, there is some value in this for us still. It would be more useful working, and I wouldn't have to replace it. But again, if I'm going to have to spend so much of my time trying to fix this, then it's not really worth the effort of going through to replace it. I don't want to change the processor board out because that runs the risk of damaging a good switch if there is something on the board. But I really think that... because I will keep this as spares, so... I suppose at the point that we have a dead switch that looks like it might be a main board, that we'd have nothing to lose by slamming a good processor on it. So I think that we'll go that route. I'll do a teardown now for you on this. There's not a lot to look at in here really. And then we'll keep the main board, the PoE board and the LED board as spares, along with the power supply and all the fans. Part of me says it would be easier to just leave it in the case and mark it as faulty. I think that's what we'll probably do. So we'll have a quick poke around this, and then we'll yeah, I think we'll do that. We'll leave it in the case and we'll mark it. So pull this out. I'll zoom you down. So this is our processor board. We have a Broadcom processor there. That I believe has its own network interface on, which is what drives the management port on the end here. Our CF card that contains our operating system. Again, actually having one of those spare is useful. We have our Snap Hat battery back CMOS with the removable top. I'm not convinced that this isn't the source of our problems, but again, it's difficult to prove it because doing anything with it doesn't really seem to change the behaviour of the board. We have some RAM. That will be EDO, I'm guessing, or possibly even DDR. We have on the back a ROM, a bit of glue logic, some more RAM, the actual power supply is there, and a PLD of some kind, I'm guessing. Yep, that's a Xilinx PLD. So our problem could be that, because we've got this LED next to this PLD that's flashing. Again, I suspect that means something to us. But with these, it's very much a case with Extreme that Summit, that they tell you just to send it back if there's anything slightly wrong looking with it. And that's all there is to this board. If you've got one of these that comes up when booting with TLD lookup failure or random panics, change all of these. That will fix it. I have had... we've got probably about 20 of these actually out in use, and we have had multiple failures on these caps. It's a quick fix, it's easy to do. You do need, as you've seen, a fairly potent iron. These don't tend to be a problem, and I've never seen any real problems with the ones on the board. They are take-on caps, which I can't say I've ever heard of. But there's just something about these ones, and I suspect, looking at where it sits, that sits in there. You've got a heatsink on this ASIC here, which is probably going to bake these. I am tempted to replace these anyway. The trouble is it then wastes caps, and it doesn't feel like the usual cap problems. So, coming down to the main board itself, we've already had a quick look at it. So what we have mostly here is the switch fabric. We have some power supply stuff here. We have some fan control stuff. It looks like we are doing some kind of control on the fans. They're not just being ramped up to full bore all the time. We have some relays over here, which I believe is to isolate the PoE when the switch hasn't booted. This thing does nothing. There are no switching functions working at all. There are some cases where on certain lower end switches where you can lose the processor board, but the switch will continue working because the processor board is used to configure the switch fabric. I have no idea what these are under here, and I want to keep this intact so I can use the board. But it is possible that these are FPGAs or similar, in which case what may well be going on is the processor's job is to load these before we go any further. These are actually going to be the interfaces for the ports. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13, which doesn't make a lot of sense. We could be doubling one up for the SFPs on the end, so that might be what's going on there. So let's just pop this LED board out, have a look at this. So you've got a ribbon cable. Oh, you are off screen slightly. We'll disconnect that mains as well because that has the potential to go bad. Can I zoom you out any more? Oh. I can, but the camera's being odd. So we have a ribbon down here for that serial port on the front. This is a scrap switch now, so I'm quite happy to leave screws out. I think for me it's easier to store this as, get that out of the way, easier to store this as a complete unit, because if this is broken up into bags it will actually occupy more space. This board is an odd shape, so it's liable to get flexed and potentially break off there. So we've got a connection down here. Can we take this front off completely? I believe we can. Not with that screwdriver. So just get these screws out the end. It looks like this entire board comes away. It looks like I'm getting low. It looks like I'm getting low on camera battery as well. It's a shame that we can't rescue it, but as I said, it's down to financials. I can replace this switch cheaply enough that it's not worth my time. We do have another Netgear one to look at, which would potentially be slightly more interesting. There we go. So yeah, you've just got your console cable on the end there. We'll pop that up there. And then our LED board lifts off, and there's really nothing to that at all. So what have we got there? They are 7/4 series shift registers. We've got 4 LEDs per shift register. They're bicolour LEDs, so that actually gives us all of 8 bits per shift register. So that's probably quite simple. And you could use that for something else, I guess. You could probably, you've got a lot of bicolour LEDs there that can be driven with just 3 pins, so there may be some use to that board. So if we go to the next level down, we have our PoE board. And I can see on the end we have another ribbon connector. And I'll look at these ICs. So this board is supplied with negative 48 volts. PoE is negative 48 volts, not positive 48 volts. I believe this probably is a hangover from the old Telcom systems that use the same. So that is going to be our data. That coming as it does over here from a power supply will be power. And then we have our 48 volt supplies. And this is just sat in on headers. Can I get a little bit of gentle leverage on these? So these will need to be walked out gradually. There we go. Pull those out. So what do we have here? So we've got 4 chips. That's 12 ports per chip, and a lot of power type tracks under there. And these are, can't quite get that. there one that's slightly more readable? PD64812G. I assume the G is for gigabyte. And then we've got something up here. This switch can provide all sorts of information about what the PoE ports are up to. So there is probably a fairly high level of smarts in here. MC4520. That is almost certainly a microcontroller. We've got our crystal next to it and everything else. So if I just bring this up, if the camera will oblige and focus, and you can just have a look along there. So there's the power over Ethernet controller chips. There's your micro with its crystal, and then we're off to the end. And I would have to say, if I guessed, we've got some opto isolation down here. There aren't an awful lot of pins being used, so I would guess quite possible this is RS-232 or something similar that's being used to talk back. So underneath we have our isolation transformers. I believe in the T version of this, quite simply, this cable isn't here, that board isn't there. That's the only difference. Whether you can retrofit them, I don't know. They may well not have the SIPs to stop you from doing that. SIPs, dip sockets to stop you from doing that. We have our SFP transceivers here, and then I'm guessing what we're doing is we are driving banks of 4. So each one of these is 4 Ethernet adapters. Then we're going up to our switch fabric here. These appear to drive that switch fabric there, so I think that's 24 ports per switch fabric. We certainly appear to have differential pairs moving. We certainly appear to have differential pairs moving between these two chips, which suggests that these are doing most of the management of the switch fabric themselves. We've got a bit more power management up there, which is possibly going to be for the processor board. We have our expansion slots here. We have a power supply here, which is providing, does it tell us? 12 volts at 14 amps and 50 volts at, that's really 17? No, 50 volts, so that's 12 volts at 14 amps and 50 volts at 7 amps. That's quite a chunky power supply. It's really well built, nice and solid. We've never had any issues with these power supplies failing. The power supplies in these are redundant, so if you look back here, you've got another output connector and an input connector on here. So I believe you can buy a unit which is just power supplies and battery backup, and then that connects in here to give redundancy. Centrifugal fan and some power management here. There's really not much to this other than that. So all I'm going to do now is just literally pop those boards back in position, put a couple of screws in the front to hold the front on, and this one will go in our storeroom as deceased. So unfortunately, I'm not willing to put any more effort into this one. So hope you maybe learn something from this one. The Netgear one probably won't be much better, but the Netgear I don't want to keep for spare, so we can really rip that one to bits. Anyway, take care. Bye.